Okay, so let us start. I will show you first. Yeah. So first of all, this is a very small example which I have made just to illustrate how Kmeans do things, do certain stuff. Okay. So let us start with this. Can you see the data points here? The data values 111 like this. See,
Okay.
I will show you through the codes. Okay. You see here, I have generated four data variables. Data 1, data 2, data 3, data 4. Can you see this? And it's
Okay.
nothing but from NumPy, I have taken random number generator. So I am generating randomly data. So I am randomly generating data. Now if you will see, I am generating two-dimensional data. So in initial third or fourth lecture, if you remember, if I do so, I have told you this random number generator. If you pass 10 comma 2, it will generate 10 numbers of two dimensions. Basically a vector of two. So like that, it will generate 10 numbers. So for data 1, data 2, data 3, data 4. For all the four variables, I am generating in total 40 numbers. Okay. And these
Okay.
random number, whatever are generated, these numbers are generated between 0 to 1. I mean, that's how the random number is there. It will be generated from 0 to 1. So what I am doing just to make clusters, I am adding some cluster centers like 3, 5, 9 and 7. You see 3, 5, 9 and 7. Like that I am generating these things. Okay. Like I can say
So
I will make it this 7 and this 9. Good enough?
what is this cluster centers?
Huh?
This is a center of cluster.
Yeah, center of C. That's what I am saying. Like I am generating the data points like this. Now
Okay.
this data is between 0 to 1.
Hmm.
Hmm. Now if I add in all this data set, if I add 3, what will happen? This will get shifted to 3.
Okay.
It will get shifted towards 3. Then
3.
if I add 5, it will go there. So just to ensure that all the four variables, all these 10, 10, 10 groups are at different places in the space. I added some
Okay.
constant value to everyone so that they go some other place in the space. So the first 10 digits, the first 10 data points will be surrounded around 3. Okay. The next will be, I will
Okay.
show you in fact. Okay. So what I did now, once this 40 random number I have generated, then what I am doing, there is a function in Python called as vertical stack, V stack. So I am basically joining all the four data points. Okay. Now,
Okay.
yeah, now I have printed that data. So you can see on this side, see I ran this data. You can see these are the 40 data points which are being generated till here. See, first 10 are 3, 3, 3, 3, 3 like this. This is like 10 comma 2, na? Then
Yes.
5, 5, 5 comma 10 numbers surrounding 5, then 7 and then 9 like this. Okay. Now Why it is first 3 and 5, and then because I have added a constant number, because random number is always generated between 0 to 1.
Okay.
Okay, so so now if you see, I will tell you this Kmeans. You see, Kmeans I have imported from this sklearn.cluster. Okay, again a sklearn library which I am using here. Okay, now
Okay.
once this sklearn.cluster I have imported this Kmeans. Now as I know that I have generated 4 variables, 4 groups basically, so I know that my number of clusters are 4. So what I am doing, I am just passing the k equal to 4 value, which the parameter is n underscore cluster here in Kmeans. So I am passing 4 values and I am training the data. I mean the unsupervised clustering is happening here by the fit function. When you say model.fit, see this is like every other model. This is like initialization of the model, and then this is the fitting, the training part of the data.
O-
Okay.
Okay.
Now printing the cluster centers. Okay. So once your data is fit, it means if you remember yesterday we have seen the whole algorithm how it does. That how it will do, the 4 clusters it will first, 4 centroid it will randomly assign first, and then initially it will initialize the 4 random centroids like mean. Okay, and then it will assign all the data points to those clusters. How? Each data point will be assigned to the nearest cluster. Remember that.
Mm-hmm.
So each data
Yes,
point
sir.
will be assigned to the nearest cluster. And then again the mean will be updated by taking the mean of all the data points coming in that particular cluster. So cluster number 1, whatever data points are coming, they will take their mean and update it. Once it is updated, again the assignment step will take place where each data point will be assigned the nearest cluster. So like that the training occurs, and that's the fit function which is doing that thing for you. Got it? So
Yeah.
now once this fit function does that, then there are two things. You can find out which data points are lying in the cluster 1 or cluster 2 or cluster 3, cluster 4, like that. Another thing is you can find out that what is the center of the cluster. So whatever clusters, 4 clusters you have learned, the center of the cluster is defined like this. Whatever model is there, there is an attribute cluster centers. You can print that. You will get the cluster centers. And there is another attribute called labels. So in this particular attribute of model, what in this particular attribute of model, what will happen that you can print the cluster, in which cluster each and every data point lies. So suppose there are 40 data points. So for all those 40 data points, what are the labels in which cluster they lie among the 4? That will get printed 0, 1, 2, 3, whatever it is. Okay.
Okay. Okay.
So that is the thing. And then I have done nothing but just scatter the data, scattered the data depending upon this class, whatever labels I have found. So how many classes are there? 4. 4, 4 not classes, but you can say 4 clusters. 0, 1, 2, 3. There are 4 clusters. So I have shown you the data. Now I will show you how to what will happen when I run it. See, I ran it. See, can you see these data points? These are the 10 data points, the yellow circle if you see, which is lying between 3 to 4. Actually, it was 0 to 1 because, as I told you, each and every data point will lie between 0 to 1 only. Whenever you will generate it with the random number, so with random number, everything will be generated between 0 and 1 only. But as I have added 3, so it has shifted to 3 to 4. This is 5 to 6. This is 7 to 8, and this is 9 to 10. Now, so once this data points are there, now this fit function has done. And see, while scattering, I have given these labels. So whatever label has come for each of these data points, so I am saying that you depending upon that you give colors. This is like the color attribute. C attribute is color attribute. So you see the all the data points which are in lying in same cluster, they are of one color. Like this is yellow, this is sky blue, this is red or something, this is blue. Okay. Now in this particular example, you can clearly see that I have artificially generated the data just to show you an example. Okay. I mean, it is not some data set or something where I am doing this Kmeans. It is just to show you the example. And this is like well defined data where I have artificially generated 4 clusters. One around 3, one around 5, one around 7, one around 9. Okay. So just to show you, I have artificially generated some clusters, 4 clusters, and by Kmeans you can see that the colors came out to be different for, I mean, all these 4 clusters, and all the data points lying in this same cluster are of same color, or are of one color basically. Okay. And as I have
Yes.
printed here the model dot cluster center and model labels, you can see these are the 4 cluster centers which it has printed, line number 28, 4 cluster centers. Okay.
Okay.
This,
Okay.
this. One cluster is around 9, 9.5. Then this one is 5, this one is 3, and this one is 7. It randomly chooses the cluster, so don't think that the zeroth, the first one should be 3, then 5, then 7, then 9. It is not in the order. Actually, it randomly chooses, so it can make anyone first. The initialization is random, na?
Yes. Yes.
So and then I have also printed the labels. See, for I in model.label. So for all the 40 points, you see the label has been given. So see, first 10 points have been given label 2. The second 10 points has been given label 1. The third 10 point given label 3. Fourth 0. As I told you, this is random, so it will not be like 0, 1, 2, 3. The thing is like unsupervisedly, without having labels, it has find the clusters. So for all the data points, whatever there are, you had, it is telling now in which cluster they fall, and that's absolutely correct. The first 10 numbers are falling in one cluster only, around 3. So that is the cluster number 2 here. Then 1, then 3, then 0. Got it? So
Okay. But
yeah,
yeah. But where is the cost for
cost.
this
Okay,
model? Yeah.
okay. So see that the cost part and basically the whole training thing, um, like you can say the assignment step, the update step. So all these things are happening in this fit function. Okay, this is a fit function where this Kmeans is happening, and this Kmeans is getting called, and this function is finally applied. n clusters and all those things. These are comments. Yeah. So it computes the what do you say, the distance. And so basically now this particular library has been written in some with some ways, like lot of functions and all. They will have their own, you know, what do you say, user defined functions and all. So maybe it will be hard to, you know, comprehend all this check array and this. They are their own libraries, like the functions which they have done. But what I can show you, like Kmeans single, okay, labels based. Okay, they are actually they maintain this hierarchy, so that is why they will do a lot of things. But the mostly the important thing here is that they will the whole computation of updation and what do you say, that the Euclidean distance calculation and everything is happening in these k-means, in this fit function basically. In fit function, and then basically this fit function is calling the other things also. Wait, yeah. So that this fit function is again calling. Oh, okay. So the fit function is again calling this k-means function. So actually, I am running
Mm.
right now this Python, na? So it will not allow me to
Okay.
go to the
Okay. Okay.
code.
Deeper.
Yeah.
Mm.
So
Yes. Yes.
it will stop, and then I have to. Shit, man. The whole spider has gone. Anyway, I will waste.
Mm. But we cannot print the cost or we
No,
cannot
no, you
check
can
the accuracy.
you can print, you can print, you can print. I will show you. I will show you.
Okay.
You can actually print. There is something called as so these libraries, when they make these things, na, like
Mm-hmm.
they will give some options to print also. It's not like that you cannot print anything, because then it will become black box. So in fit function only, or in this Kmeans, okay, I will check it on internet maybe. A scalar. There is a parameter called as verbose. Have
Okay.
I ever told you this? Verbose parameter.
Verbose.
Maybe it's,
No.
maybe I might have told you. Yeah, this one.
Verbose zero.
This parameter, if you will include this parameter, na,
Mm-hmm.
as one, you have to do verbose equal to one. Then while running, it will print lot of things. See, let's see what all it has printed. See, these were your 40 data points, right?
Yes.
Now see, it is printing. Initialization complete. I mean, initialization means 4 random centers it has initialized. Okay. Then
Mm-hmm.
sorting is done, and then all those things. Then you see this is the cost. Okay. And so iteration one, iteration in iteration zero, and then iteration one.
Mm-hmm.
See, I have artificially generated the clusters, right? So the clusters were so good that it just in one iteration only it got clustered well. Okay.
Cluster. Okay.
Then this whatever the clustering is happening, na, this will they will do it for 10 numbers of time. Every time they will initialize, every time they will do.
Mm-hmm.
So Okay, I told you one problem of Kmeans. If you remember yesterday, I will just
Yes.
reiterate that. Suppose this is one cluster, okay, and this is another cluster. Now, what is the first step in Kmeans? If you know that you can have like this two cluster, what is the first step? First step is we
Well,
initialize randomly we initialize two centers, right?
oh, yes, yes.
Now the problem with cluster is K-means clustering is, let us suppose the first point is initialized here and second initialized here. Then the bigger problem is the problem is, if unfortunately if your both the random number are lying in the same cluster, then this, I mean, nobody wants to go here, and then this will become a mess. It won't be able to
Yes.
separately find two cluster. It will do something like this and this. So it is very important to initialize at right place. You understood my problem. See, it is very necessary
Yeah, yeah.
that one initialization should be here and one should be maybe here. Then this one will tilt towards this side and this one will go this side.
Yes, I know.
But
Yeah.
how do you ensure that they are actually initialized in a good place, or they had actually started from a right place? It may happen that they fall in the local cluster, all the cluster center randomly you are assigning, so maybe randomly they fall into the same cluster. So how do you assure that? So one thing I told you that now these days they are like K-means they implement through some other algorithm. I mean not other algorithm. The algorithm is same, but they have given it a, the initialization is now a bit not random but a little bit advanced initialization is there, that is called as K-means plus plus. Okay. But in that they will say that if you initialize one cluster, then the second cluster should be far away from the first. That is one part. The another part is the another thing which people do, a practice basically. What they do is they will run k-means for 10 times. How many times?
10 times.
10 times. Yes. They will run k-means for how many times?
10.
By default 10 times. This is an
Oh,
init. Okay, you can increase this also maybe, or maybe you can decrease this also. So they will run this
mm,
k-means for 10 times. So now let's say one time it fell in the same cluster, local cluster, and the k-mean went wrong. Then when the second time you will start from beginning, initializing two centers. So maybe the second time you will find right, isn't it?
mm,
If
yeah.
not second time, maybe third time, maybe fourth time. So they run the whole k-means 10 number of time on the same data set and then choose that iteration which has minimum cost. So that is also a practice while implementation. This is also a practice which is always taken care in k-means implementation, that you should run the k-means 10 number of times and then choose, because see the when the both the centers are falling in the same cluster, at that time your cost will be high, and because both the cluster centers have fallen in the same cluster, same group, so the distance, actually if you ask me, the distance will be very high. I will tell you how. You remember cost, what I have told you? See, cost is, let's say This is the black one, and this is, let's say, another cluster center. Okay. Now you see the cost. What will be the cost here in K-means, which you want to reduce? It will be
Distance.
this distance.
Distance between centered. Yeah.
Or for all the data points, sum up this distance. Basically, xi minus, see this center, center ji. These are two. No? This is center one. This is center two. So all the data points which belong to ij. So all the data points which belong to first center, you calculate the distance, sum it up, and then maybe divide it by the whole number of data points. And then in this also add these distances. I mean I2, all the data points of I2, cluster 2 minus center. So whatever the distance are center. So now what I actually am trying to tell you is, see, maybe first time you got this one cluster center here and another cluster center here. So now if it makes a cluster like this and this one makes a cluster like this will be a blunder. The cost will be very high. Why?
Very high.
Because these distances are very high. It's a very large distances, right? So when you sum them up, you will get a very high distance, very large cost, right? But,
Yeah.
but, now here is a but. If you get the centers perfectly, finally after K-means you will get this kind of cluster. Now these costs are very small, right? So when you will add up, the cost will be minimum. When you add all these things up, the cost will be minimum. So that is what I am trying to tell you, that this cost, I mean 10 number of time you run this K-means, at least out of 10, one time so they will start from the right place, right? They will start from a good place so that then the clustering will be good. So internally it takes 10 number of times. So that is why in the implementation, if you see, it is doing for 10 times. You see, one, then two, then three, then four, five, six, seven, eight, nine, 10. No, I mean maybe I have missed somewhere. I have counted one more somewhere. So
Okay.
this is the 10th one.
Okay.
So every time, and now the data is itself I have artificially generated in a very good way. So in just in one iteration, it is getting clustered well. Just one assignment and one update, and it is clustered very well. Okay. So
Yeah.
so anyway, that was the thing. So this thing you can see. This thing you can maybe, if you do this verbose equal to 1, you will see this. The cost, they call it here as inertia. So somehow the names are different in different libraries. In SQL they call it as inertia and all. Understood?
Okay. Okay. Okay.
Okay. So now move to the second example. This This is the example which I have not generated. This is in a MATLAB file again. Kmeans ex1.mat is there, in which this file is there. So this we will see. Okay. So I am loading the this Kmeans ex1.mat. Okay. And yeah. So you see this once this MATLAB file is loaded in the data, the MATLAB file has a variable called x, in which the whole data is there. That I am taking here. Okay, what I will do, I will run only this much so that I can first show you how the data looks like. Otherwise, there is no meaning of, at least you should see how it looks like. I mean, what are the values inside? Okay, so first of all, we will see what is the shape of this data. The data is the 300 points are there, two-dimensional. Okay, if you
Mm-hmm.
want to see the data also, anyway, there is no meaning in seeing because it will be some values only. So you can see the 300 points. These are the 300 points. Okay.
Okay.
Some points these are okay. You don't need to worry. The only thing you will see the clustering. Good enough? Now,
Mm-hmm.
see, this is an example of fairly clustered data. This is an example of fairly clustered data. You will see that how it is happening. See, so once this X I have taken, now I am scattering the data point first. Simple scattering, okay. I have not performed K-means till now. Here I am performing K-means with n clusters equal to 3. I am fitting that. And then what I am doing, basically I am giving red, green and yellow, three colors to all the three clusters. Okay. And I am again scattering the same data point X two-dimensional in the these three color R, G, Y. Okay. I mean, I need not do all these funda. I should have just put Kmeans dot labels. So automatically it will give some colors. Okay. Now here I just wanted to specify RGY. That's why I have given this list of strings R, G, and Y. If I would have not given anything, it would randomly decide any color for these data points. Anyway, it's just plotting. So I am scattering the data points here after K-means. Okay, after K-means it is. So you should of course understand this thing. Okay, let us see. This is your data. Okay, now you can see here that
Okay.
it is already clustered, right? It's already a clustered thing, right? So
Mm-hmm.
but let's see. Right now you cannot say that which one is what because everything is blue in color and circle. Unsupervised learning. You
Yes.
do not know the label.
Yes.
But once you perform K-means on this, you will find like this. So all these are red ones. These are some other color. This is some other color. Red, green, and yellow basically. Got it?
Mm.
So that is the scene here. And yeah, that's it. So this we already have seen an example of fairly clustered data on artificial data. Now this was some MATLAB data on which we have seen. Now, as I showed you in Kmeans last yesterday, that what if the data is unclustered? So I will show you the data. The unclustered data looks like this. Can you see the data?
Unclustered.
This is unclustered, right?
Okay. Yes. Yes.
You see, this data is something like marks in test 1 and marks in test 2 for different students, for all these students. Now if I ask you as a principal that whatever students are there, they have got marks in two subjects, right? So whatever students are there,
Mm-hmm.
divide your class into six groups. or say first two groups. So you apply K-means on that. Whatever are nearer, it will do something like, right? So see, can you see the two groups? So so now what K-means can do if the data is not clustered, like on the base ground itself, it is not clustered, it is mixed thing. So what it will do? It will, half of them it showed red and half of them it showed green. If I had put n cluster equal to 3, then what it could have done? Maybe one this, maybe one this, maybe one this. See, three clusters. I will show you. One it has made this. One this. And the third one this. Right? You can see, na?
Hmm.
Then what if I
Yes.
make four clusters? So then it says this one has one cluster, this one has another, this one has third, and the rest, this one has four. That's what it will do. I mean, K means what else it can do? 5, 6. See how 6 it has made? These points that it has taken as one cluster, these points it has taken as another cluster. Then, then this point it has taken another cluster. This point there it has taken another. This another and this another. Right. So like this it will cluster. So whatever you give, it will try to cluster. That's what the funda is. And you see, this is also nothing. There is a Kmeans ext2.txt file. This is like marks in test 1. This is marks in test 2 for 100 students. And so for 100 students, it is like this. You see. So the data has been taken, first two columns, and then you are applying Kmeans in loop for 2, k equal to 2, for k equal to 3, then k equal to 4, k equal to 5, all the in loop we have seen this Kmeans. See, the Kmeans is here. N clusters is I. I is basically the loop number. So in loop, first 2, then 3, then 4, then 5, then 6. It is training a different K-means every time, and it is scattering the thing. How many clusters? Got this?
Okay. Okay. If you
Okay.
increase k value further,
Mm-hmm. Like
so it will
it will
like
yeah. You keep k equal to 100. What will happen? Each and every data point will become one cluster in itself. Right?
okay.
You go to 50 clusters. Now 50 clusters will do what? Two data point will come in one cluster. But
Okay.
that is not your objective, right? Actually,
Hmm.
your objective is to find the similar kind of data. Now, this was an example where you do not have similar kind of data. You have unclustered data. So anyway, you can find out 2, 3 groups here, or maybe 5, 6 groups here. But that does not make any sense that if you have 1,000 number of data, so you take 500 clusters and in each cluster there will be only 2 points. It does not make any sense. The thing is, if you have 1,000 data points and if there is hidden groupings, hidden clusters are present there, K-means can find that. K-means can basically group your data into the clusters, hidden clusters or whatever it is, the groups. And that is the main, objective, or say the power of Kmeans is that it can find the similar kind of object which are coming together in the data set, and that
Okay.
you have to decide that how many clusters you have to take. It will not make sense that if you take a lot number of clusters, what are you going to achieve? Like in market segmentation problem, I told you, for all the sizes, whatever the customer buys, they will put maximum 5 clusters. And then on the basis of that 5 clusters, they will say extra small, small, medium, large, extra large. So maybe it's like 22 to 26 waist or something will be extra small, then 26 to 30 it will be small, then 30 to 34 it will be medium, 34 to something it will be large, and then maybe above 38 it will be. So in some ranges, whatever things are coming, it will take. Got it?
Okay. Okay.
Okay. So having said that, uh, I have shown you the examples of Kmeans. Now, one last example I want to show you, that we have already seen it for KNN, but we will see it with Kmeans also. These sentences we have seen. Shit, man. Yeah, these sentences we have seen,
Yes.
right? First 10 sentences of chemistry, then 10 sentences of uh, artificial intelligence, then 10
Hmm.
sentences of finally of chemistry, right? Isn't it?
Yes. Yes. Yes.
So, uh, last time while doing that KNN also, for these things I have shown you uh, this TF-IDF vectorizer we import from this sklearn.featureextraction.txt, and this cleaning, we do cleaning and all for that. Basically what I just want to show you here is it is similar to the KNN one. In KNN we used to uh, these were the test sentences. The chemical compounds are used for preparing bombs based on some reaction. Cricket is a boring game where batsmen only enjoy, and machine learning is an area of artificial intelligence. So the same sentences were there in KNN also. What I want to show you is there I had given the three. See, here these are the 30 sentences, right? But I don't know which sentence is of which class. I mean, I know that first 10 are of cricket, another 10 is of AI, another 10 is of chemistry. But in
Hmm.
K-means, I will not treat them like that. In K-means, I will just take TF-IDF vectorizer, fit all the sentences, 30 sentences in this X, and then in the K-means, I will pass that, cluster it in three, the whole data points you cluster it in three, and whatever init and all, whatever you have to give, and then the fit the k-means.
Hmm.
That fitting I will do once I transform the 30 sentences into TF-IDF vector. I will come to that TF-IDF vector later on, as I have told you. But the whole point is you just go, and maybe if you have that video, or maybe I will send you once again if you couldn't find it. Maybe you just watch that KNN part, how I was doing in KNN. You will get the same stuff
Yeah.
here. Uh, so after applying K-means, I just I am just printing the labels of the model. I will just show you after running. And I am just printing that below three sentences will be predicted against the learned cluster. Uh, my learned clusters are somewhere, I would have said test sentences 0. Okay, okay. So this sentence, and this sentence. There are three sentences which I am predicting through the KNN model, this Kmeans model. So there are three sentences on the test data, the three sentences which I have defined here in test sentences. That test sentences also I am transforming through vectorizer into test. Now this on this 3 sentences I have predicted the label, whether it will be 0 cluster, 1 cluster, or 2 cluster, and that I am printing here. You don't worry, I will come back to this code. Just I want to show you how. See it. Yeah, there are 10 sentences of 3 class on which K-means is performed. Okay, now cricket, AI, and chemistry. So shape of training data I have printed, and so there are 30 sentences in training, 3
Mm.
sentences is testing. Once I fit it through K-means, you see the first 10 sentences have come in one cluster, the next 10 sentences have come in another cluster, and the last 10, 7 of them has come in the second cluster, but the 3 of the chemistry sentences have come in the second cluster. Maybe there will be similar kind of words or something. So there, in the training data itself, there is 3 misclassification in the third chemistry side, but that is fine. So the cricket cluster is 1, the AI cluster name is 0, and the chemistry cluster is 2. Why I can say that 1 0 into, I mean, why I can say this, because I already know that my first 10 were 1, second 10 were of AI, and the third 10 were of chemistry. If I do not know the labels, cricket or AI or chemistry, I could not have achieved this. I could not know that which one is what class. How do you know that one signifies cricket? Because you know the data. You know there are only 30
Okay.
sentences, first 10 is of cricket only.
Yeah.
But that's what K-means does. I mean, K-means does not know that first 10 is what and second 10. You are not passing the labels in K-means fit. You just see line number 66 on the left hand side. Model.fit X. You are not passing here Y. But
Okay.
internally,
Okay.
by clustering it, it finds that okay, the first 10 are of one class only. The second of 10. The third is 2. Okay.
Okay. Okay.
Now you see the below 3 sentences. The below 3 sentences will be predicted against uh, the learned cluster. This is the test sentences basically. Chemical compound, cricket is a boring game, and this machine learning. So see the first sentence when you predict it, how do you predict it? You predict it by this line. How do you predict it? You predict it by that line. Okay.
Okay.
You You can see that, na? Model.predict, and this test is basically what this is three sentence. Okay. Now, if you see here, this three things, the first sentence is predicted to be in cluster 2. So first sentence is of chemistry. So it is truly correctly predicted as in cluster 2. The second sentence, cricket is a boring game. It has been predicted in cluster 1, which is true. It's of cricket cluster only. The third is machine learning part. You see it's in 0 cluster. 0 is of course the machine learning part, the middle one. Right. So this is a text clustering thing. Now you will ask me the application, that what is the application of this whole thing. I mean,
Mm-hmm.
what is the application of text clustering? So in conventionally, let us suppose as an example, I will tell you, you are getting user complaints. All right, you are working in a bank. Let's say you are working in a bank, and you are getting user complaints, like you have a complaint, on your website you have a message box where a guy can the customers can put their complaints. So you are getting a lot of text messages as a complaint from that website. Now let's say 100 people are complaining about the password recovery, 100 people are complaining about ATM pin lost, 100 people are commenting about illegal transaction. Just an example I am telling you. Okay. Now the messages are like coming in a jumbled way to you, and you are a guy who has to manage all this message, and you need to fix it. I mean, suppose you get 300 messages in a day, you need to send those messages to the particular guy, to the particular staff who is responsible for that. Suppose you are getting ATM pin loss, so you have to reroute all those messages. You have to send to a guy who does the deals with the ATM pin.
Mm-hmm.
You have to maybe send those messages to the guy who looks into the matter of illegal transactions. Now, how do you do that? One thing is you manually go through all the 300 messages, and one by one you say, okay, ATM pin lost, okay, password, okay, illegal transaction, okay, this, okay, that. So you will have to categorize that manually. The another way is, you do not know the labels. You do not know which messages are similar, or which messages are related to ATM pin, or which messages are related to illegal transaction. You do not know anything, any label about the data. So what you do? You take the 300 messages, you convert it in vectors by TF-IDF, and then you apply K-means on that. Once you apply K-means on that, you will find that there are three clusters. And all the data points, like here in 30 sentences, you can say first 10 sentences is 1, and second 10 sentences are 0, and the third sentences are 2. Similarly, you will find that there are hundreds of messages which are of 0 cluster, hundreds of messages which are of 1 cluster, and another 100 of messages which are of 2 cluster. So at least you know that these hundreds are similar. Then you can just look at those 100. You see that in every message there is ATM pin lost kind of complaint. You can directly send all those 100 text messages which are of coming from same cluster to the guy who deals with the ATM pin loss. You can directly take all the 100 messages of third cluster, and you can put it to the guy who does the password recovery. You can directly take all the 100 messages of the second cluster and place it to the guy who looks into the matter of illegal transactions. So when you do not know which kind of messages are coming, and you need to segregate them, you apply K-means. That was the conventional way how people deals with this message. I mean, how people do the automation earlier. So this Kmeans was one of the famous way of text clustering. And why I am using why I am using it was the conventional way, because nowadays in a modern approach this, there are some new ways, deep neural network, or some new word to wake approaches has come, which does the better job, but still K-means is very effective, and still K-means is used in text clustering a lot. Why I am telling you is this, because I know this application going on in a company where people are trying to do this project, and the client is a bank only.
Okay, 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 okay.
And for the same guy, I made this example just to showcase him how he can apply K-means on that. I was, I mean, this was a 10 plus year guy in Accenture. He wanted,
Mm-hmm.
he was doing this same ML course with me, like a month, 2 months
Mm-hmm.
back. So he wanted
Okay,
something on this because they had a project like this.
okay, okay,
So this is a text clustering kind of thing which you can do.
okay.
So you can just look at. I will send you the codes. I will send you the video also.
So, so the question is, how we decide which algorithm is suitable to solve our problem?
So that's what I am telling. Na. In this particular application which I told you, see, first of
Hmm.
all these things will come with experience, man. Okay. Once you go
Yes.
doing things, once you maybe for a year, 2 years, like like now it's been 4 years for me. I have seen lot of
Hmm.
problems. You can tell me any problem. I can tell you what models people use in that and what are the techniques being used. Whether I know that technique or not, it's another matter. Like whatever, like you will be working on some domain, maybe Microsoft, some domain objectives
Yes.
here or something. Maybe there will be techniques or technologies which you don't know, but still you are aware, you will be aware about those things, like how people do, right? So similarly, once you are experienced in the machine learning field, just by experience, like you will tell me that this star rating kind of problem is there, I can tell you that okay, you use collaborative filtering there. So that kind of experience will come once you are in the field and you are seeing lots of problems, you are searching in Google a lot what how people deal with it. But that's not the answer, that is the experience kind of thing, that is a different issue. What I will
Hmm.
suggest you to look upon is like this application I told. In this application, you do not know the labels, right? You do not know
Yes.
what kind of messages are going to come. So one thing is definite, that it is going to be some unsupervised learning. You have to find a similar kind of messages. You have to find what messages are of one type or another without having the labels in prior. So definitely it's going to be unsupervised learning. Now in unsupervised, once you find out, then you can look for, okay, I have to do some kind of clustering here. So you can apply k-means there. If you have labels, if you already know that these 10 sentences are of cricket, these 10 sentences of AI, these 10 sentences of chemistry, if you already know that this is one class, then you can apply some supervised algorithms. Supervised algorithms like KNN you can apply, supervised algorithms like maybe random forest, decision tree, SVM, whatever things we have learned, those algorithms you can apply. and and definitely, yeah, more or less which works or which doesn't work, that will come with applying only. So on one data set people apply 3 4 algorithms, see in which, with what model accuracy is increasing. So like that it goes. The model which performs best, people use that.
Okay, okay, okay.
So once this ML portion will be over, na, I will suggest you to work on your own on some data sets, some problems, some machine learning thing on your own. Write
Mhm.
codes, see what are the results, try to improve on the results. So maybe participate in some competition kind of thing. Try to come in the top 200, top 100 like that. So that's that's the way you start, and it's not, of course it's not a thing which you will just just I mean learn in 1 month or something. So if you stay focused, learn a lot, do projects, do coding, definitely in 2 to 3 months you will find the difference, and you will be maybe able to approach any machine learning problem. There are a lot of problems, those are in
Mm.
research still, but yeah, at least the ones which are feasible, you can do that.
On
Kaggle,
Yeah.
Kaggle is
On Kaggle, there are a lot of information is
yeah,
available.
a lot of
Lot of
challenges
problem.
and all these things are coming up. I mean, they
Okay,
keep
okay,
on
okay,
coming, of course.
okay.
Yeah, you can take any historical data also from Kaggle, and you can test on
Hmm.
that how to do those things, how to achieve some accuracy. People also publish their kernels there. Kernel means the tutorials there for that particular data set. You
Tutorials.
can apply their way and see how the accuracies are changing. So a lot of stuff is there to do. Only thing is you have to keep on doing, keep on learning, keep on doing, keep on learning. Once you are well acquainted with this ML thing, then you can maybe approach to the deep neural networks and all. Those are like most advanced thing maybe these days. So still they need to come into market, but yeah, that is in research still. Yeah, I mean those are coming popular and most advanced things. Great.
Okay, great.
So we will stop here.